So this is a video of a modular functions question. It's question 9 from page 469 in book 4. And it first of all wants us to sketch the function f of x. And then it wants us to use the graph or the sketch to solve the absolute value of a quarter x plus 3 is greater than or equal to 3. So first of all, focusing on the sketch. The easiest thing to do here, if we're really sketching, is to figure out the x-intercept, the y-intercept, and then develop the sketch from there. So the x-axis means y equals to 0. And you might remember that this means letting the function equal to 0. And then we could go through the whole process of squaring out both sides if we wanted to, but then we'd have to factorize and solve the resulting quadratic. So actually it's probably easier to take the approach that I suggested in the video on sketching modular functions, which is to just take this expression here without the modular lines, without the absolute value lines, and let it equal to 0 and solve it for x. And if you want an explanation of how we can do this, then go back and watch that video on sketching modular functions. Okay, so I want to solve for x here. So a quarter x equals to minus 3 and x equals minus 12. So I have my x-intercept now. I also need to get the y-intercept. And of course, that just means letting x equals to 0. So effectively, I'm evaluating 0 plus 3, the absolute value of this. And this comes out as 3. And remember that really when we're looking for the y-intercept of a modular function like this, the easiest thing to do is just to take the absolute value of the constant. So again, that's just the absolute value of my plus 3, which of course is 3. And this is my y-intercept. So I want to draw my sketch now. And just before I begin to actually draw it, I want to have a think about the nature of a modular function. So I know that the modular function is going to bounce off the x-axis. And it's going to be pretty symmetrical about the x-axis as well. So if it's going to bounce off the x-axis of minus 12, and then of course it's going to hit the y-axis, well, it's 12 units away from the y-axis at that stage. So actually I'm going to go 12 units further out again. So I want to actually go out as far as minus 24. That's just to be able to see the full symmetry of that function. And that, I suppose, then is going to inform how I'm going to scale my x-axis. So I've had a quick count and I've gotten 2s out here to the left. I've actually gone a little bit below, before, or beyond, I should say, minus 24, just to give myself a bit of space. And even though I don't really expect to have to use the positive side of the x-axis, I've included a value over there just to be on the safe side. So now I'm going to mark in those intercept points, and then based on that I'm going to put together my function. So here's my x-intercept and here's my y-intercept. So I know that I'm definitely going to join those two together. But then I'm not going to go below the x-axis at all because I'm looking at the absolute value of a quarter x plus 3. So I'm going to bounce this back up again. But like I said, I've got symmetry. So I had to go across 12 and up 3 to get to this point. So I'm also going to go across 12 and up 3 to keep it symmetrical on the other side. And so my function f of x looks like this. So that's the first part done. We've sketched f of x. Now I also need to use the sketch to solve the absolute value of a quarter x plus 3, which is just f of x, is greater than or equal to 3. Well, what does this greater than or equal to 3 business mean? Well, when I say that I want it to be greater than or equal to 3, I mean that I want the function to be above 3. I want f of x to be greater than 3. Of course, we know that f of x basically means the same thing as y for this function. So I want y to be above 3. So what I'm trying to figure out is, where on my graph am I above 3 on the y-axis for this function that I've just graphed in orange? So to figure that out, I'm going to draw a line through 3 on the y-axis. So you can see I've marked that in there, going along horizontally through 3. Okay, now I need to figure out the x values that are associated with that. And the x values in question are minus 24 and 0. Okay, but it's an inequality, so I need to factor that into my solution. So I'm trying to figure out where my orange function is above this pink line, where f of x is greater than or equal to 3. So I can see that this occurs in these two regions. So below minus 24 and above 0. So for the below minus 24, it'll be x is less than or equal to minus 24. And for the above 0, it's going to be greater than or equal to 0. Notice that I include an equals part on my symbol, on my inequality symbol for my solution, because there was an equals on the symbol in the question originally as well, so I'm just reflecting that in my answer.